Let's go ahead and get started on this bell ringer. Let's go ahead and take a look at what we have. It's basically just finding the area for these four. And so what are we going to do? We're going to look and we're going to say, all right, well, I've got triangles and I've got rectangles. Area of a triangle is 1/2 base times height, just like we learned long ago. If we look here, we've got our two perpendicular measurements, our base and our height. It's probably not very easy to see because of the color that I chose. Let's make a better choice here. Here's your base, right? This 6.7. And then we know that this is the height because A, it's colored in red. That's a gigantic hint. What's the height? Look for the red dotted line. That's the height. And the other big clue that you've got the base and the height together is that they are perpendicular measurements, right? You see this right angle? The two perpendicular measurements are your base and your height. So we're going to put these things in. 1/2 times 6.7 times 4.8. And I'm going to remember this 1/2 can go to either of these, right? You're just multiplying the three things together. So 1/2 times 6.7 times. So you could take 1/2 of 6.7 or you could take 1/2 of 4.8. Me personally, I'm going to look at this and go, hey, I can take 1/2 of that pretty easily, make my life simple. So I'll turn this into 6.7 times 2.4 and solve. Just multiply them out. 7 times 4 is 28. 6 times 4 is 24 plus 2 is 26. 2 times 7 is 14. 2 times 6 is 12 plus 1 is 13. And we got 2 decimal places at the end, so our final answer here is 16.08. What's our units? Well, if these dimensions are inches, our area has to be in inches squared. I've seen it written like this, or I've seen it written instead of IN squared, I've seen SQIN, square inches. Either way, that's a choice that's up to you, but just be aware you might see that. You might see either of these. All right, let's do this one now. Same thing. 1/2 base times height. And again, look for your perpendicular measurements. This one is 6. This one is 3.2. Notice that they are on perpendicular axes to each other. This extra dotted line here helps show that the 6-yard one is perpendicular to the 3.2-yard one. So we're going to do the same thing. 1/2 base times height. And again, it doesn't matter which one you take 1/2 of, but take 1/2 of the one that's easiest. 1/2 of 6 is 3. And then multiply 3 times 3.2. 3 times 2 is 6. 3 times 3 is 9. We got 9.6 yards squared. Or again, if you prefer square, both of these ways of writing it is fine. Same thing with our rectangles, just now with a slightly different formula, right? For a rectangle, it's just base times height, right? So let's do this. 5.6 times 2.5, right? Then we go through. 6 times 5 is 30. 5 times 5 is 25 plus 3 is 28. 2 times 6 is 12. 2 times 5 is 10 plus 1 is 11. We see 2 decimal places, so carry the 1 here. Yeah, that tracks. And again, we look here, the units were kilometers. So our final answer is going to be in kilometers squared. And you'll notice here I didn't write any decimal places. I'm not concerned about significant figures. This is not chemistry or physics, so I don't care about the decimal accuracy of my answer. If you're taking chemistry or physics, you would probably leave it as 14.0, I would imagine. 1 to accuracy of 1 decimal place. Yeah, that sounds about right. But I don't care. I'm not here to do that. I'm not going to mark you wrong if you write 14.00 or 14.0 or 14. As long as your calculations are correct, the significant figures, just leave out as many significant figures as is provided to you. Again, we are not concerned about the accuracy of our measurements, right? That's the reason that they have significant figures in chemistry and physics. So we don't care about the fact that our measurement tools were only able to measure to the nearest tenth, so our answer should be reported to the nearest tenth. We just care about what's our final answer. That's all. Okay, same thing here. Base times height. Notice every time I write out the equation, right? I do that on purpose because I want to remember what I'm doing. 7 times 3 is 21. 7 times 3 is 21, plus 2 is 23. 1 decimal place. So 23.1 centimeters squared is our final area. All right, so why am I doing this? Well, today we are going to be reviewing basic area. We've already done a couple of these just now, rectangles and triangles. And so, that's stuff that you should theoretically be okay with it. We've reviewed it earlier on. We've talked about it in years past, so that should be good. But we're going to continue on practicing this as we get ready to move forward to more complicated things, all right? So let's begin. Rectangles and parallelograms, okay? We just did rectangles. But with a parallelogram, you have to be careful since it's not standing straight up, since the two consecutive sides aren't 90 degrees to each other. We can't just pick the consecutive sides and multiply them together and be done like we did in the bell ringer. Here, notice with a parallelogram, we're going to treat it much more like what we treated a triangle. The height is the perpendicular measurement because the parallelogram is tilted to the side. So, they call it an altitude here, but they call it an altitude here, but, height, altitude, same thing in terms of what we're talking about for this problem. So make sure that you're looking for that right angle here or here so that you have the correct measurements. If you don't use the correct measurements, it won't be right. And I'm telling you this right now because there's going to be problems where on purpose, I give you a bunch of extra information. You're just going to have to figure it out. Like this. Here I've got 3 different measurements, and you've got to pick which 2 are correct. Now, the easiest way to do this, again, is find this right angle right here. These are the 2 perpendicular measurements. That 4.5 inches out here, garbage. Unuseful to you. Because we're just trying to find the area, right? We don't care about anything else. So look at what we got. We got 5 inches and 4 inches, right? So once again, I'm writing out the formula. Area equals base times height. What's the base? 5 inches. What's the height? 4 inches. What's 5 times 4? 20 inches squared, right? All right. Well, then, in that case, it is your turn. I'm going to put 2 minutes on the clock. Make sure you are capable of doing this. Okay, let's go ahead and go over this. So once again, identify which ones are the right measurements. Again, look for that right angle, yeah? This 4.6 is meaningless to you. Don't use it. So we got the 2 and we got the 3.5. 3.5 times 2, 7. And our units are centimeters squared. All right. So now, notice what they're asking about is DE, this height right here, yeah? This thing. Well, in order to do this problem, we're going to need to know the area. Well, how am I going to be able to know the area if the base and the height, I don't have them both? Well, I can use the base over here and the height over here. Remember, it doesn't matter which one we use, but we have to pick 2 measurements that are a right angle to each other. So it can be like, all right, well, this side is 13, this side is 9. Let's figure out the area. Nine times 3 is 27. 9 times 1 is 9, plus 2 is 11. So we got 117 inches squared. And now, base times height here should be the same thing, right? 9.4 times x had better be 117, right? Well, let's do that. 9.4 divided by 117. Well, let's change this so I don't have to worry about decimals. So 94 goes into 117 once. Uh, 6 plus 17 is 23. 94 goes into 230. 94, 188. That should be it, 2. Got 10 minus 8 is 2. 12 minus 8 is 4. 1 minus 1 is 0. We don't have to do this for a while. They say to the nearest tenth, so we got to at least get it out to 100th place so that we can round. 94 goes into 420. 94, 188, 282, 376. That's let's see, we got 20 and then 24, so we end up with 44 here. 376 should go into 440 the same way. Let's just double check. Yeah, 64. So we don't need to go any further because they want to the nearest tenth. This 4 rounds down, so our final answer is going to be about 12.4. And then we're back to inches because we're talking about a length. We're not talking about an area anymore. Now, obviously, if you had a calculator, that would have been quicker, but, I didn't feel like clicking a couple buttons. All right. So for yours, and obviously calculators are fine. You can use a calculator if you want to. But for yours, it's going to be the same idea. I'm just not giving you a picture. So like I said, here they give you words instead of a picture. You should draw a picture. Okay, so once again, it helps to draw a picture. It's a rectangle. It's a square. Close enough. Kind of. All right, so they're telling us. No, this is not. We're gonna do this with better shapes. There we go. Look at that. All right, so they're telling us that the parallelogram has sides 15 and 18. So let's draw that out. And I'm telling you, you do this in your head, it's going to be a pain in the butt. I wouldn't do it in my head. The height going with 15 is 9. And we want to know what's the height going with 18. Well, so let's do our math here. 15 times 9. Because area equals base times height for a parallelogram, right? 59 times 5 is 45. 9 times 1 is 9, plus 4 is 13. So our area equals 135, which is the same as 18 times x, right? Well, let's do 18 divided into 135. Let me do it down here. Well, okay, so how many times does 18 go in? 18, 36, 40, 54, 60, 72, 90, 108, 108, 118, 126. 7. That's probably as best as we're going to do, right? Drop down the 0. 18 goes into 95 times. Exactly. That's nice. That's easy. So what's my height corresponding to the 18 centimeter base is 7.5 centimeters. So what did I do here? First, I found the area using the base and the height given, where I have both. And then since I want to find the height of the other one, I divided the area I found by the base. And there it was. So now let's get into triangles. We already talked about the area of a triangle. Area equals 1/2 base times height, just like you learned when you were in middle school or elementary school. So let's go on and do one more basic triangle. We already did 2 in the bell ringer, but let's do one more basic triangle problem. Then I'm going to throw a combination problem at you. You'll see what I'm talking about when we get there. So I want to know what's the area of this triangle. And I want you to notice we've got a whole bunch of mixed units. Don't try and do this when they're all together like this. Turn everything into the easiest unit to work with. In this case, it's certainly inches, right? 1 foot is 12 inches. And 1 foot plus 1 more inch is 13 inches. So let's do that. What's the area of this triangle? Is 1/2 base times height. We got the right angle there, so it's the 5 and the 12. This 13 actually is completely unnecessary. So remember, our area is 1/2 base times height. So we're going to do 1/2 times the base times the height. 1/2 of 12 is 6. And what's 6 times 5? 30. And our units were inches over here, so it's going to be inches squared for area. All right. Like I said before, this is going to be a combination. You're going to see a rectangle and a triangle. In this case, a square and a triangle, right? So you're going to go ahead and you are going to find the area of this whole figure with the box and the triangle together. Alrighty. So here's the thing that makes this tricky is that they don't like label the base of the triangle. But you know this is a square, so you know that this is 6 inches, right? So let's do the area of the square first. Base times height is 6 times 6. So the square area, is 6 times 6, which is 36 inches squared. The triangle, remember it's 1/2 base times height. 1/2 of 6 times 8 would be 24 inches, right? Squared. And then to find the area of this entire glued together figure, we just add them together, right? The square area plus the triangle area is the figure area. Let's add those together in inches squared. 6 plus 4 is 10. 3 plus 2 plus 1 is 6. So the area of the full figure is 60 inches squared.